All right, so today what we're going to do is we're going to continue our look at the binomial distribution. Remember, binomial distribution, we have two possibilities, right? It's pretty much a yes-no situation. It's either the thing you're looking for or it's not, right? Okay, and for binomial distribution, we need to have three pieces of information. So we're going to go to the book just for a moment to remind you of those. So for example, in this particular thing, in this particular question, we have a probability, and we need it as a decimal because our chart has decimals, right? We need an n. N is the number of items that you're selecting, right? And then finally, we need an x, and that is the new probability that you're looking for, right? So P is the probability that's already given. And for these straightforward questions, we have to probability. Hold on just one second. Then the n is the number of items that we are selecting. And your x is the new number that you want a probability for or of. Okay? So just have to pull out those pieces of information and make sure you're using the right one, right? Now, usually, not always, you can think of these things as, like in this case, there are 5 of them. We want to see the probability of 3. So we're finding the three out of the 5 that we're given, right? So if you think of it like that, you'll always get them in the right order. Okay. Also remember, your chart helps a bit too, because when we're doing those, remember that your probability is always at the top, and they call it pi because pi stands for P, right? And then on the side, you're given a number. So like there's 5, and then 0, 1, 2, 3. So we want 3 out of those 5. So think about that's why it's really important that you get the numbers in the right order. But your chart kind of helps you out there because you have the big number, that's everything you're looking at, and then the piece, what part of it you're looking for, right? So today what we're going to do is we're going to look at a few of these where you're going to have to pull out the information from a sentence instead of just the chart, right? We practiced last time. Be careful remember when you need to know when you include the numbers. If you're given a range, you need to know when you include it, when you don't include it, and what all of those mean. So you're still going to practice that, just like we did when we used those tables last time. Okay? Sound familiar? If not, don't worry about it. You're going to see lots of them. So let's just go to a couple of these exercises and practice some together. These begin on page 51. Right? So page 51 in your book is where we are. So the school canteen sells 2 flavors of Juicy Blocks, tropical and orange, 45%. So it's a percent. That means that is my what, guys? Probability, exactly. And we need that as a decimal, so we'll put it in as a decimal. So probability is 0.45, right? Remember, to change it to a decimal, you simply move the decimal to the left 2 places. Good. And then this is, we have our questions coming out of here. What is the theoretical probability exactly 5 out of the next 8? So do you see the wording there? Exactly 5 out of the next 8. So the number of ice blocks we have is 8, and we want to look at the probability of it, that x is exactly 5, right? So just one number. So not a range of numbers, just one in this case. Yeah. So now we have enough information. All we need is those 3 pieces of information, and then we can go to our chart and find the answer. So let me just switch over to the chart. So it's 0.5, 8, and 5, right? So going to our chart, 0.45 is here. I'm going to have to scroll down a bit, though, because 8 is down quite a bit further. So, again, 0.45 is this next to the last. Here's 8. We're going to choose 5. Going across there. There's our value. right? Because 0.45 is up here. Sorry, it just goes away on my chart because I have to scroll. Okay. So just follow down, simply the place where 8, 5, and the probability that you have where they intersect. All right? So the new probability is 0.1719. So going back to the question, think about how you need to write that. So what is the theoretical probability? Exactly 5 out of the next 8 are flavored. So probability, so we're looking for the probability that x is equal to 5, right? Because we're just looking for an exact value, and that's 0.1719. Easy. So your main job is simply pulling out the right pieces of information and then reading the chart carefully so that you don't get off the values. Now, if you want to use the formula or you want to use your calculator, go for it. I cannot imagine why on earth you would think that would be easier, but there it is. I know the other class is using their calculator for it. Poor sods. Anyway. Okay, so let's look at another one real quickly. Let's just continue on here. What is the theoretical probability that fewer than 4 of the next 8 juice boxes sold are tropical flavored? So again, the probability did not change. I'm on the wrong line. So the probability did not change. We want fewer than 4 of the next 8. So the number did not change. We still have 8 boxes to choose from. But we want fewer than 4. So can I include 4? Nope. So that means I can have none, I can have 1, I can have 2, or I can have 3. So that's the probability that x is less than 4. No little line underneath, because remember that would include 4. We don't want to include 4 in this case. So that means we have a range of values. So that means I'm going to have to find the values for each one of those and simply add them together. Yeah? So let's go to our chart. Again, 0.45, 8, 0, 1, 2, and 3 is what I want. So again, that's the next to the last column. Okay. And we want 0, 1, 2, 3. So we want those first 4 values. And again, all we're going to do is just add those together to find the probability that we need. Yeah? Okay, and no, I'm not adding those together. You can when you're doing them. Okay, let's go back to the questions and see what's next. What's the theoretical probability that at least 6 of them? So that gives us, again, the same probability, the same number. But here we want at least 6. That means 6 or what?
7, 8, 19.
Yeah, 6 or more, right? And you just go and add up all the ones as far as the chart exists and don't worry about the ones beyond that, right? Because they're so small that they're not going to affect your answer. What's the alternative to adding all of those together? Adding all the other ones and subtracting it from 1. But in this case, it wouldn't save you any time, right? Because they're probably fewer at the high end than the 6 values you would have to do from 0 through 5. Okay? What's the theoretical probability that exactly 5 of the next 8 are sold are orange flavored? Okay? Now, be careful. They've changed to orange flavored, right? Okay? So, if you go back, but we don't have a probability for orange. We could go back and just change the probability, because you know the probability is 1 minus of orange is the probability of the others. But you could also simply find the number of tropical and subtract that from 1, because if they're not tropical, they must be what? Orange. And haven't we already done this one? Right? So just go back to the one you've already done, subtract that number from 1, and that way you don't have to go to the chart, you don't have to list anything, you just find it. Right? So watch out for questions that refer back to previous questions. Okay? And then finally, what is the theoretical probability that no fewer than 6 of the next 8 juices are orange flavored? Again, we already know the probabilities, so we can just do that. Write down 4 reasons why you think the binomial distribution is appropriate for this situation and explain your reasons. So again, these questions will always appear. So make sure you remember why the binomial distribution. Here we go. It is a discrete distribution, right? Because you can't have part of a juice box. Okay. There are just how many outcomes? 2. It's either fruit or orange. So 2 outcomes. The probability of success stayed the same. And the number of trials stayed the same. And each occurrence is independent of the other. So these 4 things have to be true. Okay? Right? Probability stayed the same, they're independent, etc. All right. So we're just going to go to the book and work on some of these. There are other applications as well. They start off pretty easy by giving you those labels so that you can find reminding you that you need to find the probability, the number of items, and the number you're selecting, your X and your P and your N. And then later they stop giving you that scaffolding. So here, you see that they just they're just asking you questions. Same format, but they just don't tell you that you need P and N and X. But remember, you always need those. Always, always, always make a list of those values. Okay, even if they don't give you a spot for it. So you're going to start on page 51, and we will go through more charts with probabilities. Okay, goes through page 56. So page 51 through 56, some of them you'll have to read information from a chart, some of them you have to read information from a table. So it's going to remind you of things that you did in the probability section last year. So be aware of those, and we'll work through them if you need to.